有压力的时候，我就喝很多咖啡。所以我今天也是要 introduce 跟大家介绍一个新的 algorithm， 是我叫的 success algorithm， 跟那个看起来是像这样子。Okay. All right. So operation transformation. I'm going to switch to English. I don't think I can explain this too well in Chinese, and I don't think I'm going to explain it that well in English either. Okay. So first part is operation. Okay. The basic philosophy is that you can have a document and it can be done in two ways. One is the actual just document itself, and the other is you can have it translate into a series of functions, and those functions are called an operation. So that's operation A, same thing, hello. Retain just means you move one space forward. And once you have that, you can put more operations on top of it. So the retain 5 is important at the end. I put it in red because there's some rules to how these operations are made, and the operations have to be they have to span the same number of indexes. So if you have like a sentence, each operation has to go to the end. And that's important because once you have that, now you can combine operations together. So if you combine the operation A and operation B, then you would just get hello world. So, capital letters. So the rules of composition is that they need to be in a certain order. They have to go through the whole index each time. And the unfortunate thing is not all operations can be combined, but we're not going to talk about that today. Okay. So transformation. Okay. So what is transformation? This is Google's formula for transformation. I looked at it and I'm like, okay, how do I translate this into something people can understand? And that is my translation. It's easiest to just look at it graphically. So the basic rules is if you know the operation A and operation B, and if they are branching from the same state, then you can make a transform operation on the other end, and they will bring it back into the same state. So let's do an example. Okay, so this is how it kind of works in real life. Okay, so let's say you have the word go, and then on the server side, someone wants to add an A to the end, and on the client side, someone wants to add a T to the end. So the question is, do you get goat or goda? So what happens is, okay, both operations, operation B would be sent to the server, and if there's a race condition, server always wins. And then the server will basically create the transform on that operation and then send it back to the client. So for example, over there on the transform A, you just go 2 spots, add an A. And then for the transform B, it's go to the end and then add a T. And that way you would get go. Okay, so there's one more thing that you gotta learn before you can understand how this works. It's called bridging. And bridging solves this problem, which is, okay, you've already sent A and C to the server, but the client is still typing, so he's still creating more operations. And so the server it has A and C, so it can make the transform of A, but it can't make the transform for over there, the red. And so this is what they call is a bridge, and basically the server will retain the transform of C so that later on it can make the transform of B. Easy? Yeah? No? Okay, that's why I went first, okay? So I want to get you guys a little tired, and then everyone else who's much better presenter than me is going to bring you guys back. It's like Walking Dead. Okay, so then this is the problem, right? Okay, now if the server has to keep track of all the bridges, then it becomes complicated, right? And you know, Google, they don't like spending too much money on the server side. They want to make everything as simple and cheap as possible. So this is Google's implementation, like the philosophy and how they basically designed Google Docs. So, and the goal is to minimize server usage, right? And so the solution is actually to push all the work onto the client side or your browser. And so when you log into Google Docs, your browser actually keeps track of both not your changes, but the changes on the server side. And then Google servers can just be concentrated on tracking the changes and then notifying all the browsers. And we'll just go through an example. So, for example, you have 3 browsers, and I kind of looked at this today, and I realized that when I was working on this last night and drawing everything, I actually drew it wrong. But the basic idea is still there. So you have 3 browsers, and each of the browsers, they're working on a document, and they make a change. So you have change A, change B, and change C. Right? So on Google server, what they would do is they would first make a priority. So let's say like Google logs change A first. Well, after it logs change A, it will send that information to all the browsers. And so browser A will be like, oh, okay, I made this change, and now I got confirmed it. It knows that it's in sync with. Get rid of this. I don't have enough Skype credit, guys. The presentation's got stalled. Okay. So Google, the server will send back to the browser A and say, okay, the change that you made, it's been logged onto the server. Okay. So now the browser A knows that's in sync. And then browser B and browser C, they're going to go and work on basically adding the change on the client side. And the server has no idea. Now, the Google server says, okay, we're going to implement operation B. And then it sends the message out again. And browser B, it gets the confirms. It knows that, you know, the order and that the server got it. And then, so now it's going to basically merge and it's going to be in sync with the server again. And you see in browser C, it's creating a bridge. It's getting ready. It's waiting for the server to acknowledge that it's implemented its operation. So the biggest rules is that the server's role is that it's there to create order. So all the changes that people are making, that's the primary role of the Google Doc server. And then it's also updating all the browsers and all the clients of all the changes that are being made. And then the client-side rule is that you can only send an instruction, like a set of operations at one time. And then when you get the operation back from the server saying like, okay, like your operation has been logged by the Google Docs server, that's when you know that it's time to merge and get in sync with the server. And the way they do this is that you have a buffer. So once you send an operation out to the server, you keep typing and it just creates a buffer and it just composes all those operations into one package before it sends it out again. And there's a lot more problems that come up because of that. We're not going to go into that here today. I barely understand it. So, but one of the takeaways I just got is that you know, how do you handle complexity, right? We're iPhone developers. We're basically like the clients. So then there's probably a lot of problems that can be solved by moving all the complexity onto the client side. And resources, I can't even spell that, right? And I didn't finish that either. But Google Wave, they actually put a lot of the stuff, It's on like I think if you just look up Google Wave, the frameworks, they actually have a lot of that stuff open sourced. So you can go through it, play with it if you want. There's a lot of sample code, and that's about it. So everybody, clap your hands.